What's up, everybody? Welcome back to Electronics Wheel, and I'm here with a new project that I recently made. It is the distance measuring equipment using ultrasonic sensor based on Arduino microcontroller. This setup only requires an LCD, and additionally you need this ultrasonic sensor over here. And the what this thing does is that it send out the sound waves, and it can detect any object if it's there in the path it goes. It's pretty cool for obstacle avoiding robot and some bunch of other projects. So here I'm going to use this sensor for distance measuring equipment, which will measure our distance. And I don't have anything specially assembled except this ultrasonic sensor. So I plug in this ultrasonic sensor, make sure it's in the correct alignment, and it's all about it. We are using an Arduino. As you know before, I'm good at Arduino. We have our 10 kilo ohms potentiometer, we have our LCD display with 4 pins not used, rest all are used, and we do have a scale here for measuring the distance and for checking if it's correct or not. Let's look at how it's made, and the code and the connection wiring, and I'll come back to you with the working model.
Alright, so let's look at the code we made for this distance measuring equipment. First of all, we have included the liquid crystal library that's for our LCD display. Next, we are defining all of our LCD pins connected in Arduino, that is 7, 6, 5, 4, 3 and 2. Now, then we are defining our trigger pin from our ultrasonic sensor, that's the 11th pin connected in Arduino, and we have our echo pin, that's the 10th pin, which is connected in Arduino. Here we have our void setup, which will run the code for initial, which means that it's going to run at the beginning, and void loop will run the process after void setup, and void loop is the permanent after void setup. So void setup is just temporary. So here we gave the pin mode trigger pin. Always our trigger pin will be sending out sound waves from the ultrasonic sensor, so it is an output pin. And here we have given pin mode echo pin as input, which will collect our data, which is a sound reflected back from the object source. Now we are defining here to begin our LCD. So this intro of our LCD will be distance measuring. It's for 5 seconds. Delay is for 5 seconds, and we have our long duration. That's the R over here. We assigned a letter for that, and we have a float distance. And please note that this float distance means that this distance will be always in decimal. It doesn't have any correct integer, or it doesn't have any integer. It does include the decimal assigned to a number. Here we start our void loop, and here we have LCD clear, so this will clear our LCD, and here it will permanently show that the distance in centimeter. Here will all the processes happening here, and these are the main heart or the flag of this project. This will run our full project, and here we send out the the sound, and it returns in microseconds, that is 2 microsecond. And again it's send out, this will be in off this is in off, and again it will become active and it will be on, and it will wait, and it will have a delay for 10 microseconds. Next it will send out a trigger for, it will digitalize the trigger pin, and it will off it. And here is the mathematical calculations, which I'm not very good at, and actually I got a help from engineers to make this code, only only this part of the code. And here again we set our LCD's cursor to 0 1, which will be our second line, and we print our distance, that is this distance, it is r divided by 100.00, and we have delay of 3 microseconds. And here we have some of the additional code also to run our distance. And here it says that if distance is less than 10, it will not show the correct value, but if the distance is greater than 10, it will show the correct value. This is because the ultrasonic sensor, this is the HCSR04, which is set to be at least 4 meter, and it needs a minimum of 10 meter. That's why we assigned our distance, the distance value, as more than 10 centimeter. And these are all additional till here. This is for LED, which will not be included. Alright, so let's look at the connections from Arduino to the LCD and the ultrasonic sensor.
Alright everyone, as we have seen how the intro of the video, the programming, the wiring and all, now let's see how this thing works. So it's basically the same setup. If you want, you can have a scale too, I have over here, and nothing especially. So I got a hard disk from Western Digital, so I'm going to place it in the scale, and the scale always show in centimeters, so it's correct actually. And we'll know if it's accurate or not. Let me just show you up to this LCD screen that you can see the distance. Okay, that's good. And now let me power on the whole system. Alright, so the boot process is being done. As you can see, distance measuring. So it will take time to measure the distance. Okay, so we got the distance of this wall till here. Let me show you. This wall, we have the distance till from here, from this ultrasonic sensor to this wall. It's like 38.69. So if he places hard disk like somewhere near, what we see, let's say 13. Okay, I'm gonna place it near 13. Alright, 13.